Thanks for watching my video. Today we are going to discuss, or we are going to prove our property 9 of definite integral. That is integral of a to b, integral from a to b f of x plus g of x is integral from a to b f of x plus integral from a to b g of x. That means this integral is multiplied to our function f of x as well as g of x, okay, separately. So we can have many terms also. So let's prove this. So we know that this is equal, but we are now we are going to talk about, or we are going to prove it, okay. Now let capital f of x and g of x be the antiderivative, meaning antiderivative means the integral, okay, of f of x and g of x respectively. Then now first let's evaluate this here. Here's okay. So integral from a to b f of x dx is nothing but f of x, because this is the antiderivative of f of x, okay, from a to b, which is f of b from fundamental theorem of integral calculus, f of a. So this is one lesson. And integral from a to b g of x dx is nothing but capital G of x from a to b, and applying fundamental theorem of integral calculus is question 2. Now we have the right hand side these two, okay. Now we are going to evaluate here on left hand side. So our left hand side is this right here, this one. We know that, what did we know? Integral of f of x plus g of x dx is, this is what? Indefinite integral, okay. This is this. So if you evaluate this to f of x plus g of x, okay. So therefore our integral from a to b f of x plus g of x dx is nothing but capital F of x plus capital G of x from a to b. Okay, this inside without the limit, if you integrate, then you get this. This is from indefinite integral that I have proved, okay. You can check out there. So upper limit first, f of b plus g of b minus lower limit, okay, minus g of a. So f of b minus f of a. Now these two, let's take out as 1 plus g of b minus g of a. Let's take out this as 2. Just the same thing, just rearranging, okay. And what is this? This is equal to our equation 1, which is this one, okay. So this is integral from a to b f of x dx plus g of b minus g of a from equation 2, this one. So this is nothing but this one again, okay. So integral from a to b g of x dx. That means our property 3 is correct, right? Our property 9 is true. So integral from a to b f of x plus g of x dx is nothing but integral from a to b f of x dx plus integral from a to b g of x dx. So which proof or property? Okay,